Hello everyone. Today we will be discussing on elliptic curves over ZP. So when we are going to consider elliptic curves, all the elements on the curve or the coordinates of every point on the curve is a field element. So what is field? When we are going to consider field elements means it should all the elements except 0, all the element must have multiplicative inverse and it should have additive inverse, it should have additive identity, multiplicative identity, all these and it should satisfy commutative property, associative property, distributive property. All these laws it has to satisfy with respect to addition and multiplication. Now when we are going to consider field elements over ZP, where P indicates a prime number. So field elements over ZP means we will be using modular arithmetic. So we are going to consider mod P. Whenever we are applying mod P, we can able to consider all the elements between 0 to P minus 1. So these are the total number of elements we can consider in the field. And except 0, all the elements must have an inverse. Okay, multiplicative inverse as well as additive inverse, and it should obey all the laws. Okay, now the general expression considered for elliptic curve over ZP is y square mod P equals x cube plus ax plus b mod P. Why we are going to take mod P means we should get all the elements within the range 0 to P minus 1. So we are going to consider mod P on both the sides of the expression. And here x and y are the coordinates. It will vary from 0 to P minus 1. And similarly, a and b are the constants which are used to define a elliptic curve group. Okay, elliptic curve group means based on the value of a and b, we can able to get the different shape of the curve. Similarly, whenever the value of a and b changes, the shape of the elliptic curve will going to change, and the number of points on the elliptic curve will going to vary. Okay, so while defining elliptic curve group means a set of points on the curve for a given a and b. So in that case, how to select the value of a and b? And you have to consider one more thing, that all the values a and b must also belong to the same set, that is 0 to p minus 1. A and b randomly we cannot choose. And when we select value of a and b, then we have to check whether it satisfies the condition 4a cube plus 27b square mod p must not be equal to 0. So if it is equal to 0, then we cannot able to choose these constants to generate the elliptic curve. So in that case, once again, we have to select different values of a and b, and we have to check. Whenever the value is not equal to 0, then the values we have chosen for a and b can be used to construct the elliptic curve group. When we are going to consider the elliptic curve, we know that we are going to express every point on the elliptic curve as a every element on the curve as a point, isn't it? So every point means it will be having x coordinate as well as y coordinate. So that is the reason whenever we choose any particular point P, it will be having its own x and y coordinate. And whenever we are going to select another point Q, it will be having its own point coordinate x and y. So they are represented as xq and yq to represent coordinates of a point Q, and xp and yp to represent coordinates of a point P. This is how we will going to consider. Okay. So whenever we are going to consider any point, it will be represented by the corresponding coordinates. And if we want to perform any operation, that is addition of 2 points or multiplication of 2 points, in such case, we should consider the addition, how to perform addition. The certain rules are followed. Okay, so here we are going to consider the following four rules for addition. And as I told, every element is a field element, means it should have its corresponding inverse, additive inverse, as well as multiplicative inverse and identities. Okay, and in case of elliptic curve, whenever we are going to consider multiplication, it is treated as repeated addition. So here you can see the fourth property, that is multiplication is defined as repeated addition. If I want to consider 4 times of p, means I need to add p 4 number of times, then we are going to call it as 4 times of p. Okay, so as a result, here we are using only addition rules. And when we are going to consider addition rules, we have to consider its corresponding additive identity as well as inverse. Additive identity and additive inverse. So why we need additive identity? Because when we are going to add any value for the identity, I should get back the same value. If I consider normal addition, for example, if I consider a value 5 and I want to add with the identity such that it should give back the same number, means I can consider only 0. Suppose if I take the value 1, means 5 plus 1 will be 6, which is not same as 5. So I can consider only 0 as additive identity, which returns the same value when it is added with x. Okay. So here also, when we are performing addition of a point, we have to consider a point O such that when we add a particular point for an additive identity, I should get back the same point. So here we are going to call the point O as additive identity. It is also called as point at infinity. Okay. And the next one, what we are having is additive inverse. So why we are considering additive inverse means, see, when I add a number for a given number, I should get back the value as equal to 0 or additive identity. So in such case, if I add two numbers, the result is equal to additive identity, then those two numbers are inverse to each other. Means in this example, I can show that 5 is inverse to minus 5 and minus 5 is inverse to 5. Because when I add these two numbers, the result is 0, where 0 is taken as additive identity. This happens in normal addition. Okay. But when we are going to consider points, so in that case, what we have to consider is when we are adding 2 points, that is p plus of minus p, I should get back the point at O or infinity. Then I can call minus p as additive inverse of p. And how to represent minus p? In this expression of elliptic curve, we can notice that y square mod p is equal to x cube plus ax plus b mod p. So now, if I take the value of y as positive value, then also I'll get the same value, that is y square value will remain same. And if the value of y is negative, then also y square value will remain same. Okay, for both positive value and negative value, the value of LHS will not going to change. It will remain same. But when we are going to consider either positive value of x coordinate, I'll be getting different RHS. And if I take negative value of x coordinate, I'll be getting different RHS. Okay. But for both positive and negative value of y, I'm going to get same value in LHS. And also with respect to the general expression, means no elliptic curve over real number, we can define the elliptic curve expression as y square is equal to x cube plus ax plus b. Okay, this is the simple expression which we are going to use for cryptographic application. So from this, what we can notice is if I know the value of x, I can find out the value of y using this expression. So I can express y as square root of plus or minus square root of x cube plus ax plus b. Okay. So this indicates that y-axis, sorry, the elliptic curve is symmetric over y-axis. If I plot any curve, I'll be getting curve like this. So what it indicates, if I'm having a point here, it's exact, I mean, when I draw a straight line so that it will touch another point on the curve, which is taken as the negative point of the P, or here if I represent this point as P, then this will be considered as minus P. Okay, so like this we can able to consider the negative point of a given point. So according to that, this will be the inverse of this point and this will be the inverse of this point. So whenever I want to identify or consider minus p, in that case what we are going to do, we will going to keep the x coordinate value same, and only the sign of the y coordinate will be changed. If the sign of the y coordinate is plus, then it will be changed to minus, and if it is minus, it will be changed to plus. So whenever I want to find inverse of a point P, just change the sign of y coordinate, I'll be getting the inverse. And after changing the y coordinate value, if we perform addition, sorry, after changing the y coordinate sign, if we perform addition of these 2 points, then we are going to get the additive identity. That is nothing but point at infinity. Okay, this is how we are going to consider the negative point. So in this example, we can see if P is a point on the elliptic curve group E23 of 1, 1. So E23 of 1, 1 means 23 is a prime number and A value is 1 and B value is 1. In that elliptic curve group, if I select a point P with the coordinates 13 and 7, its corresponding negative point, that is minus P, will be equal to 13 and minus 7. Okay, and here minus, since we are considering field elements within the range 0 to P minus 1, we have to take minus P modulo 23. Okay, when I take minus P modulo, sorry, minus 7 modulo 23, I'll be getting the value as 16. So minus P value will be equal to 13 and 16, and P value will be equal to 13 and 7. So this indicates that 7 and 16 are additive inverse to each other. Here we can check we can verify with an example, that is 7 plus 16. If I add these two numbers, so what we are going to get, and then we have to take mod P, right? So when I'm going to add 7 with 16, I'll be getting 23. 23 mod 23, since P is 23, 23 mod 23 is 0. When we add two numbers, if we are getting the remainder or the modulus value as 0, then it indicates that one is the inverse of other. So as a result, here 7 is the inverse of 16 and 16 is the inverse of 7. Okay, this is how we can get negative point with respect to modulo P. Now, the third rules, what we are going to consider is if we want to add 2 points. Okay, if you want to add any 2 points, then we are going to consider the expression, that is this expression is used to find out x coordinate and this expression is used to find out y coordinate. So here lambda is called the slope. For example, when we are going to consider an elliptic curve, so here I'll just make a space. Okay. When we are going to consider an elliptic curve, so here let me consider a simple elliptic curve. So when we are considering an elliptic curve, then if I want to add 2 points, let this be P and this point be Q. Okay. So when we are going to add 2 points means I need to consider the corresponding X coordinate and Y coordinate. So here this I need to find out the slope. Okay. In order to find out the slope, I'm going to represent that as lambda. That lambda will be equal to difference between the y coordinates of both the points divided by difference between x coordinate. So we are going to get the slope. So for that, whatever the calculation we are going to do, we will be considering modulo p. And since we are cannot able to do actual division here, x is present in the denominator, difference of x is present in denominator, so we have to consider its corresponding multiplicative inverse. Okay, that we have to calculate using extended Euclidean method. So now when both the points are at different position, then we can find out the slope. Suppose if I'm going to consider a single point and then I want to add that point with itself, then I cannot get a slope. So in that case, what I'm going to do is I'll just draw a tangent and then I'll going to test where that particular tangent touches the curve. Okay, when a tangent means it will be touching only one point on the curve, so that it will pass through only one point, it will not touch 2 points. When I'm adding two different points means that will become a line segment passing through 2 points, but here tangent means it will just touch only that point on the curve, and when I extend the tangent, it somewhere touches the other point in the elliptic curve. The point where it touches, that will become equal to 2p. Okay, so here if I want to add a point to itself, in that case I'll consider p is equal to p, and then I have to consider the tangent expression. The tangent expression is defined as 3x square p plus a divided by 2yp. So now I'll going to substitute x coordinate in this position and y coordinate value of p in this position, and I'll going to compute this value. And here also we are not supposed to do actual division. We have to consider multiplicative inverse. For example, here if I want to divide 5 by 2, I can represent this as 1 by 2 into 5. So here I can get multiplication operation, and 1 by 2 is nothing but 2 inverse into 5. So now this value is same as 5 by 2, right? So in the same way here also, whenever we are going to consider get any fraction, in that case we should not perform actual division. We have to consider its corresponding multiplicative inverse using extended Euclidean algorithm. So and substitute the same thing in this expression. The x coordinate expression and y coordinate expression will remain same. The only thing is here p is equal to q means xp and xq are same if I'm adding two same points. If I'm adding different point, then xp and xq will be different. Like this we're going to compute x coordinate and y coordinate. And as I told, if I want to multiply a particular point means I need to add the point repeatedly. Then it is same as multiplication. Okay, these are the 4 things we have to remember while performing addition over elliptic curve. Okay.